have now drawn the graphs on the board for, let me look real quick, sorry. That would be question 7. Okay, these are very important when dealing with physics. If you understand these now, you're gonna be so much further along once you get to physics class. Okay, if you notice, distance is always on the vertical axis. Time is always on the x-axis. Anytime with motion graphs, you're going to notice that time is always on the horizontal axis, which that means it is always your dependent variable, and distance would be your independent variable. Okay, so number A, we have a line. Anytime a line is horizontal like this, it is not moving, okay? Only in distance versus time graphs. It looks different in an acceleration versus time graph, and I will show you in a minute. Okay, so anytime you have a line that goes straight horizontal on a distance time graph, it is not moving. Okay, let's go down to B. Show constant speed. Again, meters is on your y-axis and seconds on your x-axis, independent, dependent variables. Constant speed is a line that is going straight up, okay, rise over run, at a constant movement, okay? There's no change. That line stays the same. So every meter, you're going the same amount of seconds. And for every second, you're going the same amount of meters, if that makes sense. You're not increasing your speed or slowing your speed. It is constant, okay? Now this looks different on acceleration graph, which I'll show you in a minute. So again, this is a distance versus time. So I did the distance. It's meters versus seconds. Make sure anytime you're reading your graphs, you look at the variables. Meters per second. It could say miles per hour. It could say kilometers per minute. Make sure you pay attention to your variables. Moving on. C is speeding up. Okay, if you notice my line, it has a constant speed right here. That is constant. Okay, when it takes a jerk and goes straight up, I have sped up. My line is increased in its steepness, so therefore I sped up. Okay, on this one I changed a little bit for slowing down. Okay, I went the opposite direction, but I also decreased the angle of the line where I could have came out here, but I cut it off short to show you that it is slowing down. Okay, makes sense? All right, so there are your graphs with, okay, this is your distance time graph. These, if you remember the formula, let me zoom out. What is your formula for speed? Okay, I'm going to come up here, come around. If you remember, speed equals distance divided by time. And if you notice, every chart on this one, you can find speed, distance over time. Okay, so anytime you're looking at this, you're seeing speed. Look, distance over time, distance over time. Same one, distance over time. All of these graphs are showing speed. These are speed graphs. Okay, the next one I'm going to show you is acceleration graphs.